What's up, guys? Welcome back to the Fantastic Chemistry Podcast. My name is Pete. I am your host, and we have Tusky, which a co-host, right? And he's somewhere around here. You will see him later. Anyway, so we are on the second episode, yay, of this podcast. The first episode is about chapter one. Mostly of chapter one, I would say most, or maybe at least half of it are review. Right, and the same with chapter 2. If you had maybe like a science course in high school or middle school, you probably had it before. But if you don't remember it, don't worry about it. I'll teach you guys. Don't worry about it. Okay. And I hope that chapter 1 went well for you guys. But if you have questions, if you're not sure how I explain things, if you are confused about my explanation, don't hesitate to send me an email. We can talk about it. We can Zoom. Just do whatever you feel free to. Okay, I'm here to help you. All right, and now we're gonna go on to chapter 2 today. And before we go to chapter 2, don't forget to click like, subscribe, rate 5-star, make our podcast go viral. Leave a comment if you would like to. Okay. All right. Let's get going. All right. Now we're gonna talk about the measurement. So the measurement is the foundation of good science. No, let me take it back. No, measurement is in pretty much everything. All right. It's extended beyond science. Almost anything that you choose to do involve measurement, or I'm not sure you played sim before, all right? Measurement is in graphic design, in food measurement. I'm sure you guys have used a measuring cup before, in the medicine, and even in a fantasy football. And you guys know, if you're like it, especially the Super Bowl, an inch of a yard matters, all right? And so good measurement is pretty much in anything. And in study chemistry or science in general, it is essential to be able to make a good measurement. Okay. In this chapter, I'm going to take you through how we measure things, the limitation of each measurement, and how we communicate the measured value conveniently and effectively. Okay. Speaking of communication, let's take a look right here. All right. Now, the distance between the Earth to the Sun is about that. How many? This is million. This is 149,600 million kilometers. That's far. All right. And how do you communicate this number to your friend? Well, you can just read it. I mean, it's fine. What about this? The mass of the sun and mass of the earth. How do you communicate this number to your friends? How many? Is it millions? I don't know how many billion or billions in there. I mean, I'm gonna get lost in a way. I don't know. So with a stuff that are really big, the very big number is really difficult. It gets more difficult to communicate. Not only the big number though, the small number. For example, let's get inside the atom. Okay. So the proton, the mass of proton is that kilograms. Mass of electron is that kilogram. How do you say that to your friends? Hold on, I'm trying to make my point here. One more. Let's say if I ask you, all right, combine the mass of the earth and mass of the sun. What's the number? Well, it's gonna be really difficult, right? So, to be able to communicate and do all the operator on this number, so we need something to make it more convenient. This is really difficult to use, okay? And that's what we call it scientific notation, okay? So I'm going to scientific notation can convert this big number to just that, right? Look at the mass of the sun, just that. And the mass of the earth, look just that. Much easier, right? And here's how we do it, okay? Let's say mass of the sun is that kilogram. So look at the decimal point right there. I'm gonna move the decimal point to the right behind the first digit right here. So right now we have decimal point right here. I'm gonna move it right there, okay? Here's how we do it. Point. The 3, point. 6, point 9, go 12, 15, 18, 21, 24, 27 times, 30 times, okay? So the mass of the sun can be written as 1 point, so there's a decimal right here now, all right? So 1.98855 times 10 to the 38 times. Okay, and it's much easier. You see that? All right. The number in front of the coefficient is it a coefficient? Exponent is it exponent? The number before the exponent is called coefficient. All right, the whole thing we call multiplier, and the number 30 that's exponent. I think you know that. Okay, this is just for our communication. If I say multiplier, you look at right here, 10 to the whatever that is. If I said look at the coefficient, you know I'm talking about this guy. Okay. All right. Now let's try your turn. So pause the video right here and convert this number to a scientific notation. All right. So again, same thing. We start with the decimal right here. Move it to right behind the first digit. Okay. So how many times you move it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 times. So you can read this number as 1.496 times 10 to the 11th. Okay. We can do scientific notation, even a small number. Okay, small number. I'll give you some example right here. All right. Let's say the difficult one is gonna be the mass of electron. I'm gonna do the mass of electron. Okay. So the mass of electron. Well, that's a lot. Okay. Let's say 6, 9, 12, 15. We're going backward now. 18, 21, 24, 27, 30. 31. Go backward 31 times. All right. So we're gonna the mass of electron can be written as 9.1093836 times 10 to the negative 31st kilograms. Okay. All right. I'll have you do it right here. So pause the video, do on your own, and then check with this with me. All right. The decimals right here. So I have to move backward to right behind the first digit, right behind number 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 18, 21, 24, 27. Exactly 27 times. So 1.672629 kilo times 10 to the negative 27 kilograms. Okay. All right, let's take a look at the next video. Let's practice some more together. All right.